Go. First up, we have Frau. A little bit biased because he works for me on Vela, and we're doing some really cool stuff. And Frau will be talking about how React Native is how we're using the tokenizers in React Native. He's a systems guy, self-taught. I keep calling him boy genius, but I'll let him take it from here. All right, over to
Okay.
you, Frau.
Okay, let me just share my screen. Okay. Let me start the slides. Okay, so like Jon said, my name is Fraul. I'm working as a React Native and REST developer at Vela AI. I'm working with Jon there, and yeah, I'm from Ethiopia, Addis Ababa. I'm currently uh, like talking to you guys from there. And yeah, in today's talk, I'll be talking about how we utilized Hugging Face's tokenizer library in the app we're building at Vela. So let's get to it. So the talk will be specifically about the title is like using Hugging Face tokenizers in React Native. So we're gonna talk about like how we used Rust to make turbo modules for the Vela app. So some of you might not be familiar with the HF tokenizers library. Still, yeah, you guys can hear me, right?
Yeah, you're coming in great. Keep going.
Okay. So some of you might not be familiar with the Hugging Faces tokenized library. So that just to get started from the beginning, tokenizer is just an algorithm that you use to map like some set of bytes, or generally if you're talking about text, it's characters into a smaller units, into a smaller space, where you preserve some of their contextual information, and those tokens will be used as your vocabulary when you're talking with your AI models and stuff. So uh, so if when in the input nodes, the parameters you pass in will be these tokens. So just tokenizer converts text into a discrete set of values, or we call them tokens, and that's the thing that the AI model actually operates with and understands, and can use those as an input. So Hugging Face tokenizers is like the current industry standard for doing this. It's pretty famous. It's actually written in Rust, but they have a Python binding for it. So yeah, most people use it from Python, but like the actual library is written in Rust, and it's the industry standard. So you might be asking, like, why do you even need a tokenizer in your app? It seems like something you'd need when you're just training a model and stuff. But we at Vela are building like an AI powered inbox, and one of the features of the app is like clustering the user's emails into different clusters or labels. So like your shopping emails and your newsletters for your feed, and other stuff like that, events, extracting like the different categories of emails. So we have an AI model that lets us do that. But since like one of our values are as a company is prioritizing like local first technologies, after all we're in a LoFi.so meetup right now. So we much prefer to be able to run these AI workloads on the users' devices themselves instead of sending off their emails to a separate server. So to do that, we actually decided to run this clustering and other models in the app itself. So this is the use case we wanted to run a tokenizer. This is why we wanted to run a tokenizer in our app. But in other examples, for other use cases, for example, even if you're calling a separate, even if you're doing like your AI workloads on a separate server and you're calling an API and stuff, there are cases in which you might need a tokenizer in your app. One example would be like estimating your costs. For example, like if you have like a UI where the user inputs some text and that's directly integrated into a prompt somewhere, and you don't want to like use up all of your like input space, like input tokens in with the user's input. You might like configure a max number of tokens that could be allowed in that input and stuff. So for cases like that, you might need to run a tokenizer in your app. So in order to do this, uh, we found like the first thing we had to find was a framework or a library that would allow us to run these models on the device itself. And this is actually we found like a great tool for this called like Onyx, and they have a runtime for React Native, Onyx runtime React Native. It's not as popular as it needs to be, this library. It's actually very powerful, but every time I mention it, like most people don't know about it. So you guys should really check it out. So yeah, Onyx has a really nice APIs where we can give it the path to our model, like you see here. We load it and we download it. I guess we're not downloading it; we're just requiring it from a file. We load that and we give it the URI path on the user's file system. So inferentiation is imported from Onyx runtime React Native, and yeah, this allows us to create an inferentiation, and we can call that inferentiation with a bunch of tensors, so that those tensors will have like the tokens. So that's why we needed the tokens after all. So but like even though like Onyx runtime handles this, Onyx runtime React Native handles the actually running the AI models part of part of the project, we couldn't find like a stable like a good solution to the tokenizing. In our case, we're tokenizing image, but the tokenizing text problem. So that's the missing part we faced while we were working on this app. So, but Onyx runtime is good, but like we faced some trouble with like different data types not being supported as input and outputs. But yeah, that's a talk for another time. So the missing part was the tokenizer. So we built React Native tokenizers. So instead of like most people, uh, we saw like some examples of people like implementing their own tokenizers in JavaScript, but because we wanted like to preserve some performance and we wanted to be using the industry standard, so we don't get anything wrong and stuff. So we wanted to use HF tokenizers, so we built React Native tokenizers. So what we did with React Native tokenizers is use the React Native turbo module system to like provide a React Native API to the HF tokenized library. Like I mentioned before, the the HF tokenized library itself is actually written in Rust. So our turbo module is also written in Rust. So we can directly just import it as a Rust library and call any operations we want on it. So but after that so there is a certain problem with React Native turbo module system, because they only provide a C++ interface for it. They don't provide a C interface. So Rust only like allows like FFI integration. Like FFI is like foreign function code FFI foreign function invocation. So the FFI interface is like an interface where different native programs can call each other, can link each other, and like call each other in while operating in the same memory space and stuff. So uh, so because the turbo module system only allows the C++ FFI system, we had to use instead, if we did it manually, we would have to write some middleware interface where we output our Rust functions into a C ABI or a C FFI interface, because Rust natively supports like C FFI system or C ABI. So we can export that and have a separate C++ program that will import that Rust library. So if we'd have like to write some glue code in between, glue C++ code in between, if we wanted to like use Rust to build a turbo module. We will also have to, after writing the C++ turbo module, we would have to write a TypeScript interface for it, because like we would want to present a nicer interface, because we're planning to release it as an open source project. So yeah, so there are two glue parts we need to implement: C++ interface for the REST side, and the TypeScript interface like that goes into the C++ side. So we are planning on doing this manually, but we found another great project called Unify by Engine React Native, or we've been calling it Ubran. So what that allows us to do is like use Rust's proc macro system, or like if you like work with other languages, an attribute system. Actually, we should just move on to the code base, and will be easier to explain this with good code. So this is the project. This is the React Native tokenizers project. So if you if you take a look at it, here we're defining a custom tokenizer, so that this tokenizer holds in a tokenizer. This tokenizer is actually imported from the official Hugging Face tokenizers library. So what Unify by Engine React Native allows us to do is decorate our implement functions and stuff with this Unify export attribute, and it will automatically go over each function and like type we're exporting, and generate the appropriate C++ and TypeScript code for them. So yeah, so this made it like very easy for us. And after like using Ubran and like having successfully using it in this React Native tokenizers project, we actually also implemented an email parser interface with it. So yeah, so it's pretty capable. So to like export functions, we only need to do unify export, and for like to export objects, you have a specific like operation names like object, and to export it as a type, we also like have a record. So object exports them as a class, but if you want them like as a normal like JS object, and that's to be defined as a TypeScript type, we use this record type. So with this, we were able to like have an API for calling the Hugging Face tokenized library from TypeScript through Turbo modules. So to give you an example of how it's done, this is like a simple project we made a while ago. So if we go to app.tsx, no, I think index.tsx. No, I didn't install a bunch of stuff. Okay, I could just show you guys another example. This one might be a bit complex. So yeah, so this is an example app where like we're using a bunch of different tokenizers. So by default, the React Native tokenizers library exports all of this, the GPT-2 tokenizer, a BERT-based and a BERT-based uncased tokenizer. These are just we are mainly exporting this because these are the ones we're using in our library. If like we get more issues to expose other like tokenizers, we will add different tokenizers. It won't be a problem. But we also have like a way to load in custom tokenizers. You could do like the pre-trained tokenizer class, and this will pre-trained tokenizer dot load. It has a dot load function, and it will just allow you to download different kind of tokenizers from the Hugging Face hub. So you could just give it the name, and it will automatically download it for you. That's why there isn't a wait here. It's internally downloading it from the Hugging Face app. We've also have this custom tokenizers class. So if you give it the tokenizer as a string, and it will the tokenizer the vocabulary definition as a string, and it will create the tokenizer object for you. So to actually tokenize inputs, we have this tokenize function. So it will take in the text, and it will allow you like to pass in an enum, whether to allow special tokens or not. So like BERT and some other tokenizers have the notion of special tokens. So we allow you to configure that with an enum. And there are other functions like tokenizing with batch, getting only the token IDs. So if you tokenize, it will also give you the token IDs, their span, their like range in the actual text, like the index they start at and the index they stop at, as we saw here. Like it will give you the starting index, the ending index, and the actual token itself and the token ID. So if you don't want that, there's also a get IDs function which will get you the token IDs themselves. We also have a bash tokenize function that will get you that will allow you to pass in an array of text and yeah, and tokenize those. So yeah, so to just give you a demo, I have this recording of the app running. So let me just show you. Yeah, so it's just we're calling tokenize on each input. Yeah, so the yellow text is the token ID themselves, and the purple text is the shows the starting and ending index of that token in the original text. And we're using the digital GPT-2 tokenizer in this example, and without special tokens. Yeah, I guess that's enough. Yeah. Uh, so if we this one didn't finish starting. Yeah, I had prepared this demo, but yeah, I'm having a bunch of network problems. Uh, yeah, so this is what I wanted to show you guys. Yeah, to show you guys, this is the Unified Engine React Native docs. You should, if you are a Rust programmer, you should really check them out. They make like writing turbo modules really easy. Yeah, they're doing great work with this one. And this is the npm library. We've published this as React Native tokenizers. You can check it out. We have some basic usage documentation here. Yeah, but we'll be updating it soon. Yeah, thank you guys for listening. Yeah.
For awesome talk, bro. Our journey had started with the JavaScript tokenizers. Then we did a C++ tokenizer that we wrote ourselves. And then we implemented a Rust-based directly HF tokenizer import. This means that
Yeah.
if you stop sharing, I can move on, Fro. Uh,
Oh yeah. But I forgot to mention the benchmarking resource we got.
go for it.
Yeah, if we didn't do like actual real like official like benchmarking with it, but we did a bunch of performance now and like doing like end minus start like the basic performance tests, and we saw that like I think it was 2 times faster than the generally 2 times faster than the I don't remember, but yeah, I think it was. Oh, I
Okay.
forgot. I'm messing up.
Why don't
I
we
think it was
circle
two
back
times
and
faster than the C++ implementation. I think our original C++ implementation.
yeah, why don't you pull that up in the Q&A section? We'll circle back to you.
Sure.
The big update is like first when you go from JavaScript to any sort of memory mapped solution, you're already looking at a 10x jump usually. So first, our JavaScript tokenized implementation was really slow. Then we went to a C++ one. The Rust was actually around 5x faster than the C++, but there's like all the turbo modules, extern kind of things that are in between, so it's not as clean. But anyways, if you're doing React Native in mobile and you want to do local AI, you're going to have to squeeze every bit of performance that you can find. Next up, we have Diplomatic by Mason Simon. Uh, he's been around. He's been around the valley and currently dialing in from Barcelona, which makes me really jealous. But I'll hand it over to you, Mason.
All right. Well, thanks, Jans, for hosting this and putting together this community, which has been great. I'm glad to know there are other people who share my weird interest in this topic.
Yeah.
So, if you saw the slide that Jans had up a moment ago, this is about my sync engine, which I call Diplomatic. and I call it a single player sync engine. So there have been many people who posted many different sync engines in this form. So yeah, I'll get to what I think's distinctive about mine, but let me just start with why single player and like why I'm building this thing, how I came up with it. I've been an app developer for many years, a web developer since I was a kid, but I've been doing like iOS and Android, etc., professionally for quite a while now. And frankly, I'm sick of it. I want to go back to web apps. But there are some things that you get in the native world that, like automatic data sync, iOS has facilities for this, that I don't think we really have a good answer for on the web yet. So let's see. Maybe you've heard of headless software, like headless CMSs, which are, a back end with no front end. So what I want is, let me see if I can coin a new term. I want to build tailless apps. The thing I love is building the front end software that people interact with. And I don't like building, not so much I don't like building the back end, as I don't like maintaining a back end. It's, setting up a simple back end for a piece of software is not that hard. There are a lot of things that'll help you spin up a back end on the internet easily now. But if you think about actually running and maintaining a back end, particularly one that's supporting software that other people are going to use, it's an enormous burden because you've got to make sure this thing's running all the time, which means you have to have an on-call rotation because everybody sleeps. And if your backend breaks while you're sleeping, then it's going to be offline for at least 8 hours. That's no fun. If you want to go on some sort of silent technologyless, meditation retreat, you're going to have someone else on your team who's willing to do, the on-call rotation the whole time while you're away. It's a lot of trouble. So that's sort of like professionally why you might want back-endless software. But really, how I came up with this thing I'm working on now, my diplomatic protocol, is for a long time I've kept a journal, and I've kept a journal on paper. I've kept it in just a ton of different forms, text files, Evernote, etc. And they've each got some weaknesses. Paper, you can only write on it when you've got a pen, you've got your notebook in front of you. The longer you keep your journal, the more physical space it takes up. You have to haul this thing around. So obviously that's not great. Software is a good solution because, bits don't take up any more physical space in your bags. Okay, but then we've got this back end problem where if I want to keep my journal, well, I don't want to have it just live on one device on my phone. Because if I lose my phone, then my journal's gone. So it's got to sync, right? But a journal is inherently private. You don't want to sync your private journal in plain text on somebody else's servers. Okay, so what do? Well, you can self-host your own server, but then you run into all the problems I mentioned before. I don't want to do sysadmin. Okay, so what's the solution to this? Is I think it's encrypted data, synchronized, and hosted on servers that someone else maintains for you. So that's basically what I'm building. Now, even once you have encrypted your data, so I said hosted on someone else's servers, but we need someone else to host those servers for us. So I'm building this protocol in which I've written a couple different server implementations. One simple one you can run basically in Node on your own systems. One you can host on Cloudflare's infrastructure. And that's the main place that I'm hosting it at the moment. But my ultimate goal is I want to make this single player encrypted sync protocol that's so great and front end developers love it so much. There's so much demand for it that someone else will host it for me. So that's why I'm talking to all of you about this and building this project and talking about it in public. All right. So let me go ahead and just show the diagram. Okay. I think you can all see this. it is, this is probably not a unique diagram. I suspect that many other people have come up with roughly the same structure, but let me just talk through it. So the way my sync protocol works is you've got what I've labeled the view over here. This is basically your front end application. User clicks buttons within this thing. And the actions that represent those button clicks, like make a new note or like check off a box in your to-do list, those generate what I call operations, or it's labeled op for short in here. So all user actions are captured as events that I call ops. Each of those ops goes into this DSL thing, the diplomatic sync layer. That encrypts these things with the user's private key and then ships it off. So it does two things simultaneously. One, ship it off to the cloud host, where the cloud host sticks it in storage. And then the other thing is it runs it through the front end's operation handler, which determines how do you update the local client state in response to that action the user took. And you can see that there's a bidirectional arrow here. So the host can also ship operations back to the client's diplomatic sync layer. And it all runs through the same code path, whether the user initiated the action on the local device or they're receiving an operation representing an action they initiated on a different device. So you run it through the handler on the client that changes something about the client's internal state. And then there's hook, because this is at the moment targeted towards React, although it's not specific to it. So then the client can react to state changes, which then update the view. And then the client, continues the cycle. User clicks a different button, generates new ops, etc. Okay, I'm not going to talk through all the details below about the particular encryption algorithms, etc., because I don't think they're all that. They're important, but not really for the purpose of getting the concepts. Okay, so this is not a CRDT-based sync engine. That's one thing I think worth pointing out. And there's a reason for that, which is, one, it might be my ignorance, but from my research into CRDTs, it seems like you're going to need to keep the full history. Maybe this is not true of all of them, but you're going to need to keep a lot of CRDT data to reconstruct your current state of things. Whereas with my system, there's something not pictured. There's really only one kind of operation a user can do, and that is an update. So, or it's an upsert rather. So every single user action is represented as either an insert or an update to something I call an entity. So this is something like a note the user's editing or like a to-do that they're checking off a box in. Everything is just either insert or update a complete description of what that entity is. So if the user's writing notes, for instance, every update contains the full current state of the note as they're typing it, which might seem wasteful, but it results in a major simplification, and simplicity is a huge goal in this system. And the simplification is that whatever the latest operation is that applies to a particular entity, that's the only thing you need in order to reconstruct the current state of the system. So when a user performs 3 updates to the same entity, you can just throw away the first 2. Now, client may retain the full history if you want to be able to do undos, but if you're space constrained, which at some point you might be, then you can easily just prune off old operations. So what I like about this is you can think of the working set of the client's data state. It's all the entities that are not deleted. And your data requirements are always going to be linear in the size of that working set, meaning you're not going to be like monotonically increasing how much data storage you've got. Okay, so that's one thing I like about this system. Let me go back to my notes. How much time do I have left, by the way?
You're good
I'm
for
not quite
another
at time
5
at the
to
moment,
10.
right?
Yeah, you're good.
Okay, cool. Okay, so I alluded to something, the entities. Let me see. Let me talk briefly about how I'm building this thing. It's I think the right way to build a protocol is you build a protocol and an application in tandem, which is what I'm doing, to figure out what the protocol needs to support. So the app I've been working on, I call Life. This is really, it's not a journal I wanted to build the whole time. It's a total life management system, which is a combination of a journal and a super to-do list that's more than just checkboxes about what to do today, but it is like checkboxes about what to do next quarter or like next decade of your life. So this is something I wanted to build for many years, but I basically couldn't because I was like, I'm going to be putting all this private stuff in here. It's got to be encrypted, and I don't have time for this now. So anyway, like about 6 months or so, I started to build it and decided I did have time to build this whole system. Okay, so there's a coming back to the system architecture diagram. There's a little piece that has evolved in this system that's not shown here yet, which is something I call entity DB, which has made this very nice productive system for building, for building apps. So it's um, in between that, let's see, what it basically is it is this handler component here of the system. So when the client receives a new operation, I've added this component called entity DB to my diplomatic sync system where uh, every operation has an entity ID. So it has to uniquely identify all the different pieces of client state that it's operating on. And this entity DB is just a database that's indexed by that entity DB. When it receives a new operation, it just overwrites whatever used to be there. And then let's see, what else is there to it? Okay, so it's not a fully fledged relational database because this app I'm building is a web app. Like I've said, I'm trying to avoid building native apps ever again. And unfortunately, web apps don't have a relational database layer. It used to exist. It was called Web SQL, and it was just every browser had SQLite built in. And then various of the browser vendors decided that they didn't like that anymore, and they wanted to just build their own database from scratch. And they came up with IndexedDB, which has a lot of problems, but it's what we've got. So it's what I'm building on for the moment. Okay. Let's see, where else should I go with this? Okay, how about what are the benefits to adopting this system or one like it? But I'll talk about mine in particular. Uh, if you build your app on this system, you automatically get built-in file import and export, in addition to being able to do sync. And I think the file import export's very valuable because that's one piece of not being locked into any vendor or even really like the sync protocol you've chosen to use. Because the file format is very simply, it's just basically a folder full of all these operations. Okay, so that's one nice feature of it. Let's see. How about where's it going? What's left to do? Um, like I've said, I'm building this in tandem with the app, and mostly I'm focused on the app at the moment because the sync architecture seems to work pretty well. But there are a few things I'm coming across that I know will need to be resolved. So one of those is at the moment, it's end-to-end encrypted, which means that the client has to have an encryption key. And what I'm doing is I'm forcing people to either generate or, well, yeah, to generate a new encryption key before they can start using any app that's using this protocol. That means that the onboarding kind of sucks because people have to be presented with a screen that says, like, click a button to generate a private encryption key. And you have to explain what is this private encryption key. And then it's very important that you store it and you don't lose it. Maybe I can demo this part for the moment. Just like one more minute and I'll be done here. Okay, so here's onboarding at the moment for my life management app. So you generate your secure seed. You've got, it's like 128 bits of random data. Okay, but then you have to type in an account name. The reason you have to do this is because I'm using the browser's password manager to store your private key. If someone hits not now, they're in trouble. Or if they use this app in what do you call it, private mode, they may not get this prompt. Okay, so ideally we wouldn't have to do this, and I can see a way that we might not have to, but as long as you're end-to-end encrypting everything, you're going to have a private key. So what I'm thinking of is maybe I automatically generate a private key that's the initial one you're using, and all the data operations you generate are initially encrypted with that. And then you can graduate to generating your own private key. And then I don't know if we want to re-encrypt everything that was previously temporarily encrypted or what, or maybe the initial stuff isn't encrypted yet, and then you can't sync it until you generate your private key. Okay, so that's like one thing to figure out. Um, Another thing at the moment, there's no way to permanently delete data, but maybe people want that. Uh, that's probably got to be worked into the protocol somehow. And then the last thing that I think is potentially very interesting is, um, do you have a different private key for every app you use in this system? Or do we want to have a system in which apps have unique identities? So each app has an identifier and you know how to distinguish the data made in each app, but it's all pooled so that you could have, maybe you want to have multiple different apps looking at the same set of data. I'm not sure yet. And if anyone's thought through these things or knows good references to look at, please let me know. But uh, I'll cut it off here for now.
Cool talk, Mason. This graduate to uh, your own personal cloud is kind of an interesting pattern some people are following. If you mind, stop sharing and then I can pull up Dan's intro. Some ideas have been instead of logging in, you sort of add approval to sync to an app. There've been stories like Enter, some personal cloud things. And then in terms of key management, there's been some interesting things with passkeys, but it goes back to that same adage, it's like turning hard problems into crypto problems. Uh, Next up, we have Dan Wexler. I'm quite stoked for his talk, and it dovetails really well with Frau's Rust talk. So I'm excited to see what he has in store for us. Can't stop streaming. There we go. There we go. All right, over to you, Dan.
Hey guys, nice to meet you. I'm Dan Wexler. I actually am kind of surprised how much there's similarity between our talks. It's pretty neat. I'm using tokenizers in my app. I don't really talk about them in this talk, but I do use them when we're doing text search. We tokenize our text and then run it through Roberta model and use the embedding that results from that. So that relates to the first talk. And the second talk, that's really interesting. I wanted to mention, I'll be mentioning a product called PG Lite, which is a Postgres that runs in the browser. It's actually a WASM build of Postgres in its single threaded mode, and it runs in the browser using WASM and it persists into IndexedDB, or you can persist into many different things. And it's built by a company called Electric. And they make a sync product, which sounds very similar to what our second talk was about. So a lot of related stuff going on here. Anyway, my background, I was in the visual effects world for a long time at PDI DreamWorks. And then since then, I've started a few companies that do ML-based or machine learning-based search. I've been working on that for the last few years. So I really come from the image side of the world where we're making imagery, and my first my apps that did search that I did companies with were all searching for images inside of videos. And then a few months ago, a composer friend of mine said, "Hey, I need that, but I do audio. I don't do images. So I need an audio version." And that was really interesting for me to hear because turns out audio search is actually more valuable, I think, than image and video based search, and I'll get into that. So to start with, so Aster is a local first audio search app. You can type text and it'll search and find related audio. You can actually also give it audio and it will find similar sounding audio as well. It's entirely an ML based thing. I don't really talk about that when I talk about it publicly, but for this group I do. Normally I just say search, and it's a little different. There are existing search apps out there, and so it's easier to describe in that sense. So why local first? Well, it turns out that media professionals, both image and audio ones, all of their data lives locally on their local desktop. The data does not live in the cloud. They don't put their data in the cloud. I have been waiting for media professionals to put their data in the cloud for like 15 years now, expecting that that was going to happen. And it just hasn't happened. And that's largely because they use desktop applications like Pro Tools and Avid, and those work with local files. And so actually what they've done instead is like the professionals, when they work with a big company like, LucasArts or any one of these big DreamWorks studios, whatever, they have proprietary tools that actually they copy a file from the on-premise network that the studio has to the contractors like the composers and the media professionals to their local machines at home. They have a synced directory, and it's not done with Drive or anything like that. It's just a dedicated proprietary way of syncing that data. But essentially, it's because they need to work with the data locally. So what I've done instead is I've taken what I built originally as sort of a normal service-based back-end, front-end architecture, and I've reworked it all into a local first app. And like Mason was saying, it's tailless. There is no there is no back-end server. We have no servers on the back end. The only server that's there is just a static server for downloading the JavaScript. You just go to the website and run the app, but it's actually running more like a desktop app than anything else. And that's local first, but it's also kind of not local first in that I don't really sync with a server or anything remote. It's really more like a desktop application. So why audio search? Well, like I was saying, it turns out audio, you search for it a lot more than you search for video. Now it's fun searching for video because it looks pretty when you see all the results of bridges when you search for bridge, but you don't really search and use the results of a search as part of a workflow as a composer or an editor. You know the things you're going to edit. You've been working with them for days. You have them already prepped in your editing tool, and you're just dropping them in. You're not searching to find the next clip to drop in or anything like that. But for audio, you do. So for audio, you have heard the same soundtracks on many different films. Like Vivaldi's The Planets has been used on dozens of films. Not to mention that, but studios will reuse the music from their older films on new ones because they paid for it already. It's easier to deal with. And for the composers, they have a very practical problem. How do they get work? Well, the companies, they send out a job bid, and the job bid is basically a text description of the kind of audio they're looking for, like a typed out, filled with adjectives kind of description of what they're looking for. Short audio, it has a bright sound, and all these different things. And then sometimes they include a couple of sample tracks that give the sense of what they're looking for. And then the composer takes that and has to find in their local collections examples of those music that they've made themselves and they own, and package those up and send those back as a bid on the job. And so that's really one of the most common use cases. Audio professionals also, like certain ones like sound effects artists, they will want to browse and find sounds to use when they're constructing a soundscape. And that's a case where you're actually using search as part of your workflow to construct, to create a new audio track. And what they're doing there, I think of as browsing more than searching. Searching, I think of as I know I have this file. Where the heck is it? I need to go find it. Browsing is I want to find eerie horror background music, and it gives you a result of 50 or 100 things, and you sort of search through those for what you're looking for. So to give you a sense of what this is like, I'll run this little demo. And I'll get started here in a sec. This is my audio, it's not actually similar to what my customers use. These are just a bunch of my albums. I think I have like 40 of my albums that I just did here. Now they have very different files, small sound effects files that have one sound in it. These are larger, longer tracks, but it gets the idea across. So the first thing that we're going to do is we're going to use the browser's file system API to request access to the files on the local system. Once we get access to that local repository, we're going to index it and process it. And that might take many hours, even several days, to process all that and store it. And then once it's been processed and indexed, you can search it. And I'm going to skip the indexing part. I'll give you a sense of what it's like to get started. You know, it brings up the browser picker here, and it tries to give them feedback about the processing while it's happening. I'll freeze it here for a sec. So this is showing a little display that it talks about how fast it's processing and which kinds of things it's processing. There's a few places you can see this in the app, and I'll come back to why that's important. Anyway, the indexing can go on for several hours, and then once it's finished, let me make this a little louder. Uh, okay, you can start to do search. So for instance, you can search for simple things like piano. Hopefully you can hear that. Let me make it a little louder. Or you can do like more sophisticated searches like guitar solos. Or different genres, different emotional contexts. You can do all these searches. You can also, like I was mentioning, you can search for audio. I held my phone up here and recorded a Grateful Dead track, and I didn't have any Grateful Dead sounds in the thing for it to find, but it found some stuff kind of close. So anyway, you can do this searching. Turn this down a little bit now. So you can do the searching, and then once you found things or along the way while you've done stuff, you can use the things on the right to bookmark what you found, and then there's a little collection. You can make different collections and download the collections. But that's basically the idea of the app, is that you do that sort of fancy browsing. Oops, and oops, go into the next slide, please. No, no, it keeps wanting to play it here. Okay, better. So you do that sort of browsing, you find stuff, and all of that was just from the ML analysis. Like there were no file names used there, there's no text that was used there, there's no regular database. It's just doing an ML search. And to do that ML search, it uses a model called CLAP. CLAP is a contrastive language audio pre-training model. It evolved from a model called CLIP, which was made by OpenAI, that did the same thing for images. And so it turns out actually that to do it with audio, you don't do it with audio, you do it with images. You turn your audio into images, and that's what this image here is. It's a MEL spectrogram. On the bottom is time, and then frequencies are vertical. And so you get this image that represents a segment of audio, 5 seconds, 10 seconds, and then you give that to the Hugging Face clap model, and it gives you back an embedding. So we are using the Hugging Face models, just like the first speaker. Our model is a Leon model, which is trained on a wonderful public data set they came up with 630,000 pairs of audio and a paragraph of text. So it essentially learns the relationships between sounds in audio and text. And then we use cosine similarity, which is a standard way of finding similar items in an ML embedding, or when you have these kinds of embeddings, either from the tokenizers that we were hearing about earlier on, which I use as well, or from the audio tracks. And then how does the indexing work? Well, the first thing, as I mentioned, we use the file system API to get permission. Unfortunately, this only works on Chrome or Edge, does not work on mobile. None of that stuff works on mobile yet. Obviously, we could do almost everything else on mobile. File system access is a little weird on mobile. We use a function called show directory picker, which allows you to pick that folder. And that's also kind of unique. So Safari doesn't do these things, and Firefox, they have crazy feelings about it. But Chrome and Edge, they do it, and it works on Chrome and Edge, which is enough for now. We use also this ONNX, or I think it's called Onyx, model, which allows us to run in the browser. And the latest version actually has GPU support, which makes a huge difference for doing the sort of processing that I'm doing. It's many times, probably 8 to 10x faster to do it on the GPU. Um, Currently, we're only doing inference with this application. I'm actually looking at doing some fine tuning with the users' data, but we haven't really got that to actually produce enough of a benefit yet. And so when we run the Onyx model with CLAP, we get this 512 element vector back, and that's what we store in the database. So in our database, which is this Postgres PG-Lite database, we store these 512 embeddings for every 5 seconds of audio in the input. And that's a lot of embeddings. I'll come to that in a section. And then we use this cosine similarity, and there's an extension to Postgres called PG Vector, which really makes that much faster. That's also included in PG Lite, as are a whole bunch of other extensions, by the way. And then we do that all in web workers in the background. So we can spin up, like by default, we spin up like 4 web workers, and they're just reading files, breaking them into 5-second segments, running them through CLAP, and storing them in the database. So that's sort of how the indexing process works. There's some problems with that. Browsers aren't really designed to do heavy duty processing, especially not background processing. That's not really what they're for. And they have a lot of things that make that kind of frustrating. Um, my customers will have hundreds of hours of music, like many days of solid music, and that gets translated into hundreds of thousands of 5-second segments. So we're doing this work in the background, and it works. It's nice and stable. Web workers work great. They last. The browser can, this computer can go to sleep and things wake up, and it keeps going. I mean, amazing stuff happens, but it does take a long time. And the biggest issue is that if you don't keep the browser in the foreground and the tab that you're working on as the foreground tab, then the browser throttles the web workers, and it throttles them a lot. It slows them way down. And so a task that might only take 4 hours if you left it in focus could end up taking several days of user time to do it. And that's very different than what people expect from an application that's running in the browser. I mean, it's a desktop application, so they should think of it more like Photoshop or Avid, but it's running in the browser, so they actually think of it as a web app, and that disconnect of expectations can cause a bunch of problems. I could get around some of those things if I ported this to Electron. That allows me to run with Node in the background, doesn't do the throttling, some stuff like that. Oh, and I should mention this app is free and open source. Anybody can use it. There's no money involved in anything. If it got wildly popular, maybe I would do something, but for now, it's just a free open source fun project that I'm working on. So a couple things, and then we've done local first. Debugging is tough. Computers go to sleep when my processing stops. They have different hardware configurations. Some of them have GPUs, some of them don't. Some of them have big machines, some of them don't. That's really different than when you're working with a server where you can control exactly what the hardware configuration is. Also, debugging their files when they have trouble is really hard because we don't have the files, and they don't like to send them to us. And so debugging that can be really tricky. And as Mason mentioned, there are lots of these browser-based permission things that can come up that can cause trouble. So if you ask for permission for someone's folder, you get it and you're processing, and then they go away and they do something else and they come back to the app and it asks them again if the app can still have offline permission. And if they click no, then the app is in the middle of processing and no longer can get the files, and everything goes terrible. So there's some frustrating things about it being local first. And just some other fun bits if you want to read about that are on the blog. Just displaying waveforms for audio is a whole art in and of itself. You may not have ever thought about that before, but there's a bunch of fun things that can go wrong with that. I have a little article about that. Finding those segments within longer files, I talked a little bit about that, and I did a performance comparison between the web GPU stuff, which is what Onyx is using in the browser. They also have a WASM backup for when I don't have a GPU on the machine, versus the Python CUDA version of Onyx. And it turns out, short story, pretty darn good, the browser processing. And since most of the time in this application is reading files from disk and processing them with ONNX, The JavaScript doesn't matter at all. The only thing that's really missing from the browser-based version is a way to batch up and do inference on a whole batch of things at once. That's another way to really take advantage of bigger GPUs. That's not quite there yet in the Onyx browser implementation, but I think it's coming. Anyway, there's more about that on the blog, and I can stop there. Thanks, guys. Thank you, Jans, for setting this up, and for the other talks. It was really great to hear all this stuff.
For sure, for sure. And thank you for the wonderful presentation, Brian. I'm gonna stop the recording and then invite everyone to this stage.